Hello. In previous lecture, we have discussed the properties of discrete time systems, and we have discussed that there are the different properties of the discrete time systems. There is a linear, nonlinear property, time varying, time invariant, causal, non-causal, stable and unstable, dynamic and static, invertibility and inverse. So out of these, we have already discussed linear and nonlinear systems, and the linear and a nonlinear system, this is the property of the discrete time system. For the system to be linear, the system must obey the superposition law, and whenever the superposition law obeyed by the given system, it must follow the homogeneity and additive properties. So we already discussed this, and we also find if this x1 and x2, these are the excitation, and y1 and y2 are the responses, means output, then if the additive property and homogeneity property. So additive property, if both these inputs are applied at simultaneously, and when these inputs are applied separately, that is a homogeneous property. So when these inputs are applied simultaneously, we will get like this: x1 plus x2 is equal to y1 plus y2. And therefore, suppose these are the inputs, then homogeneity when these signals are applied separately, and therefore this is the input and this is the output. And when these signals are applied simultaneously, it will obey the superposition theorem, and output which is obtained by the superposition theorem like this. So this is the weighted sum of the input, and this is the weighted sum of the output. And therefore we also discuss some examples. So linear, non-linear system we have discussed. We have discussed the time varying and time invariant system. Now we'll discuss the causal and non-causal systems. Non-causal discrete time system. Okay, so a discrete time system is said to be causal. A discrete time systems is said to be causal if the response of the system depends on the present or the past value past input applied. So if the output of the system or the response of the system depends on the present or the past value of the system, then that system is called as the causal. And if this condition is not fulfilled, then the system is called as the non-causal. Means the system is non-causal if the output depends on the future input. We'll discuss whether we'll discuss some examples and where to find whether the given systems are causal or non-causal. So y of n is equal to x of n minus 1. Check the causality of the system, means whether the system is causal or non-causal. So according to the definition, if the output of the system, that is y-plane, if this output is depends on the present as well as the past value, then that system is causal. So past value will first put here y of 0 is equal to x of 0 minus 1. This is equal to x of minus 1. So this is the output. Uh, this is the output of the system. Okay. So this output depends on the, this is the input. This output, present output depends on the past value of x of n, because this is the output at y of 0 and this is the input we have given to the system at x is equal to minus 1. So therefore output depends on the past value of x of n, hence the system is causal. The system is causal. Okay. So next we'll consider another example. Y of n minus 1 is equal to x of n. Check whether the system is causal or non-causal. So again put here y is equal to n is equal to 0. If you put here 0, then this is x of 0. So output is like this. So this output is at minus 1 and the input is at x is equal to 0. Therefore output is depending on the future value of the input. So this is the future input. This is a future input and therefore this is the output, and output is depending on the future input. Therefore this is not fulfilling the condition of causality and therefore the system is non-causal. Consider another example. So y of 0 is equal to sine of x of 0 and therefore y of minus 1 is equal to sine of x of minus 1. So the output is depends on the present value, hence the system is causal. Output and the system is causal. Next we will discuss the stable and unstable system. Next property of the discrete time system: stable and unstable system. A discrete time system is said to be stable if for any bounded input it produces a bounded output. If for the bounded input it produces the bounded output, then we can say that your system is stable. Okay, means from that, suppose the impulse response, the output of this system is equal to summation over minus infinity to infinity, and this is the impulse response h of n. This magnitude is less than infinity, then we can say it is a absolutely summable. Is absolutely summable, and therefore for the bounded input, for a bounded input, the input is x of n, magnitude of x of n is less than or equal to this response, that is m of x, which is less than infinity. Therefore this value is greater than or equal to x of n and less than infinity, then that input we can say it is a bounded input. Similarly for the output, for the bounded output, your output magnitude of this output should be between these values. So from about to these two equations, we can say that the y of m output is equal to summation over n equal to minus infinity to infinity. Your response should be less than infinity. Then and then your system is bounded. Means we can say for bounded input output is bounded. So and your system will be stable. So let us consider one example. Check whether the given system is stable or not. So y of n is equal to sine of x of n. So this is the input, x of n is the input. So if x of n is bounded, then sine of x is also bounded. Or suppose if x of n is bounded sine x of h, sine x of n is also bounded, and so y of n is also bounded, and the system is stable. Next is the static and dynamic system. This is the one of the properties of the discrete time system. So static means the If the output of the system depends on the present value only and not on the past or future values of the excitation, then that system you can call it as a static system. Means the output of the system depends on the present value, not the past as well as future. That system is called as the static systems. And if the output of the system depends on past as well as future values at the same time on the present value, then that system is called as the dynamic system. Okay, so a discrete time system is static if the output depends on the present if the output depends on the present value only and not on past or future values. Okay, that system is called the static system. And static system is also called as the memoryless because this is also called memoryless system. And if the system depends on past as well as future, that means it is having some memory. So that system is called as the memory system. So dynamic system is the memory system. In which output depends on past, present, and future values, and it is a memory system. So let us discuss about the example. Suppose the example is given if y of n is equal to x of 3n, and check whether the system is check the system is static or dynamic. So the solution y of n is equal to x of 3, and y of, suppose you put -1, you will get x of -3. Okay, so y of -1 depends on the future value. So this is the output at y equals to y of n. So at 1, the output, it's this value depends upon the future values, not on x of 1, but this depends on x of 3. That means this is a future value, not the present value. Okay, that's why this is the not static system, but this is a, we can say it is the dynamic system. The system is dynamic. Let us consider another example. Y of n is equal to sine of x of n. Therefore, y of 0 is equal to sine of x of 0 y of 1 is equal to sine of x of 1. So the output depends on present value. This is a present value. This is also present value. So this is the output which is depends on this present value. This is not depending on the past or future values, and we can call the system is static. The system is next. We'll discuss the invertible and inverse discrete time system. The last property of the discrete time system, invertible and inverse system. A discrete time system is said to be invertible if the distinct input leads to distinct output, and if the system is invertible, then an inverse system exists. If the system is invertible, then the inverse system is exist for that. So suppose the system is given to you. This is your input x of n, and here you will get the output which is equal to summation over k equal to minus infinity to infinity x of k, and this is here we will get y of n, and this y of n input is applied to the system, which will you will get w of n is equal to y of n minus y of n minus 1, and this is equal to omega n equal to x of n. So this is your system. To the input is applied x of n, you will get the output y of n, and this is the inverse system. Inverse system. So when you apply the output, we will get the input. We get the input. So let us consider this system. The input x of n produces the output y of n, and this system is cascaded, means connected in series with the inverse system, and the output of this system is nothing but the difference of two successive input, that is y of n minus y of n minus 1, and this is the input to the original system. This is the input to the original system. So therefore, by connecting an inverse system in cascade with the original system, the excitation signal xn is re-established. We will get the input signal again re-established, provided the original system must be invertible. And this concept is generally used in communications, because we must recover the original signal. We must. So let us consider one example, and we have to determine whether the given system is static, causal, time invariant, linear, and stable. Means we have to check this property of the given signal. So the function is given to is y of n is equal to x of 4n plus 1. So here y of 0 is equal to x of 1. If you put here, so this output, it depends on the future value, and the system is, this is dynamic system as well as non-causal system, because the output is depends upon the future value. Next is, suppose the output of this system is delayed, the output due to the delayed input. So this is output due to the delayed input is like this. The output is delayed by n naught. If you substitute value here, so this is the output delayed by the output due to the delayed input. Now the delayed output due to the input, we can write like this: y of n minus n naught is equal to x of 4 of n minus n naught plus 1, and therefore this is x of 4n minus 4n naught plus 1, and we can say that this, the output due to the delayed input and delayed output due to this input, they are not equal, and hence we can say that this is a time variant system. This is time variant system. Next is, suppose we have to check now linear or non-linear system. So a1 y1 of n is equal to a1 x1 of 4n plus 1, a2 y2 of n is equal to a2 x2 4n plus 1, and therefore the output due to the weighted sum of the output y3 of n, a1 y1 of n plus a2 y2 of n, and therefore we can write, substitute here value, a1 x of 4n plus 1 plus a2 x2 of 4n plus 1, and this y4 of n is equal to a1 x1 of 4n plus 1 plus a2 x2 of 4n plus 1, and therefore y3 of n is equal to y4 of n, and the system is, we can say it is a y4 of n, and the system is linear. So in this way we can find whether the given system is causal, non-causal, statics, and dynamics, like that. Thanks for watching the video. Thanks.